So now what we're going to do is we're going to zoom in. So let's go here. Right here, we're just looking at this world view, right? The whole globe is in picture right here. We're going to zoom in to like, multi-states, maybe within one particular state or two particular states, that kind of distance, something you might see on a sectional chart or maybe a couple sectional charts, that kind of scale of distance. And when we get down to that, we have different effects, but they're also effects that are caused by, again, differential heating of the sun on the surface. And in this is just one example of how we get on a more zoomed in scale, we get even more, and this is where weather gets really complex. And let me go back up to the globe. Let me go back up to this one. Let's do this one, right? So in general, we said all this is warm, right? Yeah, all this is like medium, and then all this is cold. But in reality, right, you might have a pocket of colder air, relatively colder air here within the Tropic of Cancer, and you might have a pocket of relatively warm air, and they mix and at a more kind of granular level. So that's kind of what we're talking about here. We're kind of zooming in away from the generalizations that we made for the whole entire globe. And when we do that, one of the ways that you get pockets of warm air and pockets of cooled air is from the sun heating the Earth's surface differently, whether it's land, like dirt, or water, like the sea or a lake or something. Okay, it takes more energy to heat water than it does land. Okay, so it takes more energy, more time, the sun beaming down on the water to heat it. And it at the same time, it also takes more time for the sea to cool. So what you get is, and on the flip side of that, you get land that heats and cools faster than water. So in the day, in the morning, the sun's beaming down and it heats up the land faster than it heats up the water. So we get a point, by midday, mid-morning, where the land is warmer than the sea or the lake, right? So then the air above the land also gets heated, right? Because it's like radiating heat into the air above it. And that heat starts to rise because it's less dense. And what happens when it rises? It creates a void, and you get the cooler air from over the sea or over the lake come and fill in. And then now we have a more granular circulation pattern. Again, similar concepts with the thermodynamics of, heat, just at a more granular level on something that we as general aviation pilots, will actually fly through, right? And then at night, it's the opposite. You get radiation cooling from the land that cools the land faster. So you get to a point where actually the sea is warmer than the land because the land cooled off so fast and the sea is struggling to cool off. So now you have this situation where the sea or the lake is warmer and the land is cooler. So now the air above the land is cooler, the air above the sea is warmer, and that warm air rises. And then you have the cold air. Oops, that should be blue. Filling the void underneath, and you get this circulation pattern in the opposite direction at night. Okay, so that's just one example. Again, same concepts, but it's creating packets of warm air and packets of cool air that are then mixing, right? And interacting with one another.